I'm a hot air balloon that could go to space with the air. It might seem crazy what I'm about to say. Sunshine, she's here. You can take a break. Hot air balloon that could go to space. Like the air, like I don't care, baby, by the way. Because I'm happy, I'm alone if you feel like a room without a roof. Because I'm happy, I'm alone if you feel like happiness is the truth. Because I'm happy, I'm alone if you know what happiness is to you. Because I'm happy, I'm alone if you feel like that's what you want to do. Here come bad news, talking this and that. Yeah, well, give me all you got, don't hold it back. Yeah, well, I should probably warn you, I'll be just fine. Yeah, no offense to you, don't waste your time. Here's why. Because I'm happy, I'm alone if you feel like a room without a roof. Because I'm happy, I'm alone if you feel like happiness is the truth. Because I'm happy, I'm alone if you know what happiness is to you. Because I'm happy, I'm alone if you feel like that's what you want to do. Bring me down, can't none bring me down. Your love is too high. Bring me down, can't none bring me down. I said, bring me down, can't none bring me down. Your love is too high. Bring me down, can't none bring me down. I said, because I'm happy, I'm alone.
Could you guys hear the music, or was I just okay? All right, cool.
If you feel like a room without a roof, because I'm happy, clap along if you feel like happiness is the truth. Because I'm happy,
We got 15 in here so far.
what happiness is to you. Because I'm happy, clap along if you feel like that's what you want to do. Because I'm happy, clap along if you feel like a room without a roof. Because I'm happy, clap along if you feel like happiness is the truth. Because I'm happy, clap along if you know what happiness is to you. Because I'm happy, clap along if you feel.
There we go. Now more people coming in.
Bring me down, can't none bring me down. Your love is too high. Bring me down, can't none bring me down. I said, because I'm happy, clap along if you
18 are in here. I don't know. I can't remember how many we have. We'll get going here in a little bit.
Clap along if you know what happiness is to you. Clap along if you feel like that's what you want to do. Because I'm happy. Clap along if you feel like a room without a roof.
All right. I knew I could figure it out how to play music for you guys. You can't go without that. So that was karaoke Monday, I guess. All right, we got 8-3 to do. So we're going to do 8-3 pretty much all week, 8-3 day 1 and day 2. Then Friday, we're going to have a little quiz. Seems like if you look at the website, and I've updated, so make sure every time you go on my website that you're refreshing so you see the latest version. And I think we have it planned out pretty much to the end of the year. There might be some slight adjustments along the way, but for the most part, it should, I think it should stay how it is. All right, let's see, we need to share. I need to share the screen. Here are the notes. I try to post these early, at least. I'll try to get caught up on posting these much earlier so you have a chance to print them out if you have that opportunity if you have a printer at home. Otherwise, I guess I would just suggest notebook paper, and you can just look at them as we go, or look at the screen, of course. But anyway, we have more on vectors. We have angle between two vectors. If theta is angle between non-zero vectors, A and B, in other words, the vector has to have some sort of length. It can't be 0, 0. Cosine of the angle is equal to A dot B. I shouldn't say times. It's not times. It's called dot product. And over, this is magnitude. So magnitude of A and magnitude of B. And this comes from the law of cosines. There's a whole proof of it. There's a whole way to to go from the law of cosines to this. I don't remember if I do it in the video or not, or on Edpuzzle, but you can take a look at that, and you can sure give a bunch of proofs for it, I'm sure. But just take it from me that this actually works. Here we're going to find the angle theta between vectors u and v to the nearest tenth of a degree. So I need calculator. Let's, I'm going to, oh, come on. Boom, there we go. I should have had this ready. It's kind of ready. Move that over here, turn that on and clear it. All right, so the cosine of the angle between these two vectors, and you can see it off to the right, the answer to the whole degree is 125. They went to the nearest tenth. Excuse me. So we already kind of know the answer, but we need A dot B. So in other words, U dot V. So we need U dot V over the magnitude of U times the magnitude of V. So the dot product is we take 6 times -4. You multiply the x's together. That's -24. And this is always add. That is always, always, always add. So we're either going to add a positive or we're going to add a negative. Well, here we add a positive. So we multiply the x's, multiply the y's. So that's +6 over. Now I need the magnitude of this vector right here, which is Pythagorean theorem. Square root of 36 plus 4, so square root of 40. And then times the square root of the magnitude of this vector over here, which is 16 plus 9. So I need -18. Well, the cosine of the angle is -18 over the square root of 40 times the square root of 25, which we know is going to be 5. Now, there's no reason to simplify this because we're going to get this to be a decimal value. There's a couple ways to get this answer. We can do -18. How about divided by square root of 40? Get that answer, and then divide by square root of 25, which we know is 5. So dividing by each of these separately. That's probably the easiest way to do it. Now, the cosine needs to be between -1 and 1, because now we're going to take the inverse cosine of this value. So if it's outside of -1 or 1, you did something wrong. You're going to get an error in the calculator anyway. But we're going to use this whole value. So we're going to do the inverse cosine of the answer. And we get the answer they want is 124.7 degrees, but in the diagram, they just rounded that to 125, nearest tenth of a degree. Questions on that problem? So you need to know this little formula. There's not a lot of formulas you're going to need to know for this test. This is one of them right there. You got to know that one. I have a second monitor, so that's why I'm kind of looking off to the right. I put your beautiful faces over to the right there. Same thing. So we have cosine of theta is equal to -12. I guess I should just do this. -12, this is the dot product, plus 12 over the square root of, oh, you know what? I need to change this. Hold on. Stop. I'm listening to you in a different, I got to select a different, wait, listen. There we go. Now I can actually hear you guys. Share. I had to change some things because of the music, so I had to switch that. All right, anyway, so -12 plus 12. And then there's really no reason to go on with this because that's going to be 0 on the top, but I will anyway. 16 plus 4, 16 plus 4, and square root of 9 plus 36, but that's just going to be 0 anyway. So here we have cosine of theta is equal to 0, and now we want to know where cosine is 0. Well, that's at 90 degrees. So anytime your dot product is 0, we say that the two orthogonal. We say that the two vectors are orthogonal. In other words, they're forming a 90-degree angle. So we have to kind of know that that means 90 degrees. And for some reason, they don't say perpendicular. They don't say 90 degrees. They have a word for perpendicular vectors. It's called orthogonal. But hopefully that kind of shows you why when the dot product is 0, the two vectors are at 90 degrees, because the inverse cosine of 0 is 90 degrees. Now that's example 3. We're gonna go backwards now, and I think since that explains it at least a little bit why 0 is orthogonal, then I'd show you, well, let's just focus in on dot product. So letter A, it says find the dot product of u and v, then determine if u and v are orthogonal to each other. So the dot product is multiply the x's, -12, multiply the y's. I think we just had this problem right here. I might have picked the same values. That's +12, and that's 0. So we say, yes, they are orthogonal to each other. The dot product is 0. Therefore, the inverse cosine of 0 is 90 degrees. Here we have u dot v is equal to 16 plus 20, 36. So they're just not 90 degrees. And we could probably go on and find that angle, but that's not what this problem is asking for. Use a dot product to find the magnitude. It turns out that A dot A, so the dot product with itself, is equal to the magnitude of A squared. So you get a little bit too much when you do the dot product. So let's do that. Let's repeat A, -5 and 12. And so the magnitude of A squared is equal to 25. And what we're doing is we're doing part of the Pythagorean theorem. We're doing the A squared plus the B squared, or in other words, the Y squared. So 144. So 169 is the magnitude squared. So we need to square root both sides. Square root. So A, the magnitude of A, excuse me, is equal to 13. And you might think, well, why didn't we just find the magnitude? Because it would be the square root of 25 plus 144. But it says use the dot product to do that. So there's the dot product. There's the process. We don't have the square root in the dot product, and you eventually have to square root. So it's just a much longer version of just finding the magnitude. That's all it really is. It's not much more to it than that. Questions on that one? All right. Next. Oh, well, that's it for 8.3. There's not a lot to it, really. There's this formula, finding the angle between two vectors, talking a little bit about dot product. And yeah, there's not much to it that we cover. Now, there's a lot more in the section, but bottom line is we don't cover everything that's in the book. We just do a very quick version of chapter 8. We do a quick version of chapter 9. And then we call that good, because all that extra stuff you don't really need for calculus, at least not what we cover. So with that being said, that gives us a lot of time to review. So I thought this is kind of the tougher stuff, so let's do one of these. A plane has a bearing of 54 or 054 really with a speed of 380 knots. So that is going northeast. So let's draw it like this. And let's get some labels here. Well, if this right here on a true bearing is 054, in other words, 54 degrees, then the unit circle is 36 degrees, because they should add to 90. Now the magnitude is 380. There is a wind with a bearing of 250 and a speed of 60 knots. So it doesn't say from. So we're not going to go in the opposite direction. We're going to go in the direction of 250 degrees. Now remember, that always starts at north. So there's 90, there's 180. All the way would be 270. So we're stopping 20 degrees short of that. So here's the wind right here at 60 knots. And we want the result. We want the resulting path right here. That's what we're after. But we need the unit circle measurement of that 250. So from the positive x-axis, we're going to go 90, we're going to go 180. And remember, we stopped 20 degrees short of 270, so that should be 20 degrees. So that's 200. 200. So now the plane is 380 cosine of 36 and 380 sine of 36. The wind is 60 cosine of 200 and 60 sine of 200. Let's go to our calculator. And we have 380 cosine of 36 plus 60 cosine of 200. So the result is 251.044. Keep on going. Let's store that into A. So we're going to call that A. 380 sine of 36 plus 60 sine of 200. And we have 202.837, and we'll call that B, and we could just as easily call it X and Y if we wanted to. So now the magnitude of R, or in other words, the speed of the resulting speed, is the square root of A squared plus B squared. Magnitude is just Pythagorean theorem. Square root of A squared plus B squared. And as I've said before, by storing this information, we should all have the exact same answer. So 322, let's say 0.7 knots. Now the angle. And this gets a little tricky because we end up, this is true bearing, 051. So that's the answer. Let's try to get it. And we're going to do the inverse tangent of B over A. So inverse tangent of B divided by A. And it's saying 38.9 degrees, let's say, but that, notice the green is the answer. And what the calculator just gave us is the unit circle measurement. That's all it knows, 38.9. But we want the angle to the true bearing. We want to know how many degrees this is right here. So we just subtract from 90. So we'll take 90 minus that answer, and that's where you get that 51 degrees. So 051 degrees. Any questions on that process? I'll leave that up a little bit. Let me take a drink here and I'll let you catch up if you're writing that down.
So we're not trying to find the angle inside the triangle, the one on the outside.
Well, you know, when our calculator got us that triangle right there, got us the unit circle angle right there. But the problem is given in true bearing measurements. So we're going to answer questions in the format that it's given. So if we would have done quadrant ones where it was like, remember, north 25 degrees east, if that's the way it was given, then that's how I would expect the answer. So you got to know those as well. Look at Megan getting, I don't know if you can, you probably can't see Megan right now. Is it cold out there? She's outside. A little cold to be outside today. Of course, it was, what was it, Saturday? What was it, 72 on Saturday? Crazy, isn't it? All right, we got a lot of time left. We got 12 minutes left. Let's do a few problems, and I'll cut you loose a little early if we're done here. Find the dot product of U and V, then determine if U and V are orthogonal. Quite frankly, I don't know if you're doing odds or evens or all or what, so let's just pick one. Let's pick something relatively small. How about number one? Got 18. So number one, the dot product is 18 plus -10. Now it's always addition. So then you just decide what's the sign on that one. That's 8, and that's a no. Can we find one that is orthogonal? You guys see one that is? Can you do some quick math? 2 and
Number
3.
three.
2 and 3. I think 2 and 3 are right. So if we did number 2, we got 80. When we multiply the x's, oh, did I get, did someone's, oh yeah, someone did in chat. 3, very good. That's right. That's right. I got to remember to check my little chat thing here too. Yeah, 3 is also 0. That's right. I just happened to grab number 2. So 80 minus 80, because that's going to be negative 80, 0. Don't forget to answer yes on that, because it says then determine if U and V are orthogonal. Yes or no is just fine. Use the dot product to find the magnitude of the given vector. So let's grab 10, I suppose. It turns out that the magnitude squared is m dot m. So the dot product with itself. So negative 311 dot product with negative 311. And it's kind of the first part of the Pythagorean theorem is what you end up doing. That's why it ends up being squared. So 9 plus 121, that's the dot product. Multiply the x's, multiply the y's, always addition. So the magnitude squared is this. So we want A, magnitude of A, is the square root of 130, and I'm not really aware of any perfect squares in 130, so that would just be the answer. Find the angle theta between U and V to the nearest tenth of a degree. You might as well, that one looks, yeah, that's fine. So number 16 is the cosine of the angle is U dot V. So 0 plus 20. So 0, 20 over the square root of 25, because it's actually 0 squared plus 25 squared. That'll end up being, you know, I mean, how long is the vector that has the components 0, negative 5? Well, 1, 2, 4, 5, that's down here. So that just has a length of 5, of course. So that'll be 5. Then times the square root of 1 plus 16. So we need 20 over 5 square root of 17. And that'll be the cosine of the angle. So 20 divided by, we could do divided by, now if you don't want to do it, divide separately, you just need parentheses, of course. 50 square root of 20. No need to simplify square root of 20 because we're just going to get a decimal value for this anyway. So that's 0.89, which is good news. It's between negative 1 and 1. So 0.894. Now we just need to do the inverse cosine of the answer. And we get about 26, let's say 26.6 degrees. Well, let's do this. Let's go 1, negative 4, 1, and then negative 4. And that seems like a very skinny angle, very narrow, very acute angle. And so 26.6 makes perfect sense. Now on these problems, you don't have to diagram them. That's not necessary. You just have to know the formula. But if you want to see if your answer makes sense, you could probably do a quick little sketch and decide if you did the math right, if you have the formula right. Now, I don't want something like, let's do one more. I don't want this to be tricky. This is just the vector negative 1, negative 3, and this is negative 7, negative 3, like that. Shouldn't, I mean, do I even have to do any work with this one? Negative 1, 1, 2, oh yeah, I probably do. Negative 1, negative 3. Yeah. Don't even ask what I was thinking. Anyway, cosine of theta is equal to, we need the dot product. So 7 plus 9. So we multiply the x's, multiply the y's. That's the dot product, and it's always add. Over square root of 1 plus 9 and square root of 49 plus 9. So 18 over, I need square root of 10 and square root of 58. 18, how about we do this? Divide by square root of 10. This is how I think this is easier, just to divide once and then divide again. I always like to do the calculator in the way that I think I would make the least mistakes. So cosine of theta is equal to 0.747. Good news, we have something between negative 1 and 1, probably doing this right. So inverse cosine of the answer, and the angle between the two to the nearest tenth is 41.6 degrees. I don't think I have anything after that. I think that's it. All right, you guys, 8-3, there's not a whole lot to it. Make sure you know those bearing problems. The assignment is out of the book. Now, out of the book goes pretty quick. So we have a worksheet for you as well. Make sure you get the worksheet done. It's 4 of those bearing problems. So overall, it's going to be like a regular assignment, but hopefully the book part goes pretty quick. I mean, doing the dot product is just a little bit of multiplying and adding. You should be able to do that. Like, you should be able to crank those out pretty fast. I think I'm pretty sure I opened up a spot on Google Classroom for the assignment. You guys are doing a good job of letting me know when I need to do something. Hey, I got this assignment done. Make sure you get, or Mr. Smith, I think you need the Google assignment up there or whatever. So I'm always an email away from helping you out. I had one student ask me a question. I made a video of the homework. I can always do that. If you want to go, hey, Mr. Smith, I'm having trouble with number 37. I'm really set up with a lot of fancy little equipment here, and it doesn't take me long to throw up a video real quick. So if you need that, just shoot me an email. I'll be happy to do some of that stuff.
Okay.
Any questions? Oh, Nathan. Hi, Nate. How's it going, buddy? I don't know if he's still there. Anything else for the good of the cause? It is 3:10. I'm gonna cut you here loose about 5 minutes early. Enjoy the day. It's nice and sunny out. Maybe go for a walk or whatever you need to do. Kind of cold though still. But that's it. That's all I got for you. We'll see you Thursday. Bye-bye. No, Wednesday. Bye-bye.
He waved at me. Oh, your mic's on. Hey, Mr. Smith.
How's it going, bud? How's college?
Oh, it's okay.
Yeah. Just okay.
Yeah, they teach calculus differently out there.
Is it more of a